Okay, so 6.3 is rotations. A rotation is a figure, or the definition is, a figure is rotated about a fixed point. A fixed point. And it will tell you either to turn it 90 degrees, 180 degrees, 270 degrees, and then it'll say clockwise or counterclockwise. Okay? So we're going to do examples in the book straight away on this one. Just 2 examples. So as soon as you're done writing that down, turn to page 478. I'm going to pass out to you guys what's called patty paper, and it's like a tracing paper. You might want to go grab a graph paper to do this so that you can experience this.
Is this place different when you go to the doctor's office?
Yeah, it's exactly like that.
That's
That's where I got it from. I waited till everyone was done using it for the day and then dug it out of the trash. Who needs one? Can you get one? Or I got one. Oh. Did everyone down there, it should be, can you pass it down? Is everyone on the ends getting a piece? Everyone needs one. Do we have enough?
This is enough.
You have extra? I'll take your extra. Alright, so are you on page 478? I'm going to show you how to work this stuff. It's like really cool.
Is it really the stuff in the doctor's office though?
No.
Allie, that's why I love you. You just believe me.
Like.
Okay, so here's how we do this. Alright. Thanks for being so quiet for everyone at home. Alright, 478. We're going to do 1 and 2. Okay, be really careful. This paper tears easily and you're going to want to use it quite a bit today, so just be careful. Alright, so the first one, it says we need to graph it, so let's graph it. We have 3, -1. So go over 3, down 1, and that's x. And then we have 5, -4. Graph that. That's y. And then we have 1, -5. And that's z. So you have a triangle, right? Okay. So this one says we need to rotate it. Okay, and then we're going to give the new coordinates. So we're going to rotate 270 degrees counterclockwise about the vertex x. This is the vertex, right? It's a point. That's a place where the points meet. Okay. So what you can do, the easiest thing to do, okay, we know 270 degrees is 3 turns counterclockwise. But what's easier? Anyone think of something that's easier than going 3 turns left? What?
Trace this
Wait, no, someone just said it. Bryce?
counterclockwise once.
Yeah, counterclockwise 1 turn. Do you get what I mean? Because if you go 3 times that way, it's the same as going 1 time this way. Right? Okay. So take like just some, like maybe a corner. You don't want to use the whole thing, so maybe a corner. And I want you to just carefully trace your triangle again and label it too. It's really important that you label it so you know where you're going from. Okay? And then take the tip of your pencil after you trace it and put it on X, because it told us to go on X, didn't it? Okay, and we want to carefully try to turn this 1 turn, like 90 degrees clockwise, because that's the opposite of 270 counterclockwise. Okay? So keep your pencil on it, And then just spin your paper, do your best to go 90 degrees, right? So that means like our Y is going to be somewhere like over here, right? So 90 degrees. 90 degrees. And since you have a square paper, and if you squared yours up like I did, you should just have to turn it like this. 90 degrees. Did you see what I did? Can you see it? You want me to do it again?
Wait. Lift up the thing. I can't.
Okay, I'm going to go back. Okay, so I have mine in the corner, and my paper's pretty much level. I mean, it's not perfect. And I'm going to turn it 90 degrees to the right so that it's kind of like flat again. So 90 degrees to the right is the opposite of 270 to the left, right? Okay, now do you see it? Do you see what happened?
That's amazing.
It is really cool, right? Now you love this stuff. Okay, so now when I look at it, instead of me drawing it right now, I'm going to kind of like put my left hand, because I'm right-handed. You could switch hands if you're not. And I'm going to just hold it there. I'm not going to move it. And I know that it has space to write in the top, but I covered that up. So I'm going to write x prime. Did x prime change? Did x change, you guys? No. So write 3, -1 again. And then I have y prime. Where did the y go to? It went over here, right? So what is this point? This is 0, -3. Let's see. Oh, -3. Don't forget the negative, like I did. And z prime is now over here, which looks like -1, +1. Okay? This is just easier to do it this way. Some people, they spin it and then they try to draw it and then they try to write these down. Don't you think it's easier to write them and then draw it? I'm thinking it is. So now I can take my patty paper away. Right? And now I can just plot these points. So x prime is the same. Y prime is 0, -3. So put a y prime there. And z prime was -1, 1. And now I connect those dots. Cool, right? You didn't know you could do this with the doctor's office paper, did you? Should we try number 2? Number 2 is slightly different. Number 2, we're going to graph the same exact triangle, but we're just going to move it differently. Okay? And number 2 is probably a lot more like what you're going to see on your test, because it says about the origin. The origin is 0, 0, right? Okay. So again, let's graph this. So this was what? Right here. That's x. And then y was right here. And then z was right here. Oops, did I miss one? 1, 2, 3, 4. Oh, it's a different graph, isn't it? A little bit. Because that's 1, 1, 2, 3, 4, 5. Yeah, it's a little slightly different graph. Same picture though. Okay. Everyone have that? This one's going to be a little bit harder because my book is bent. But it should look like that, right guys? Okay. Now 180 degrees is 2 turns. It doesn't matter which direction you go, does it? 180? Okay. And then it's about the origin. So all you have to do, just find another spot a little bit farther away from your first triangle so you don't get confused. Actually, are they the same shape? No, they're different. Too bad, because they changed our graph on us. Okay. So redraw it, retrace it, I mean. Put your Z and your X and your Y. Did I draw it wrong? Let me see. Let me see. 3, -1. 5, -4. 1, 2, 3, 4. Oops. You're right. You're right. It should be right here, huh? That's 5. 1, 2, 3, 4, 5. -4. 1, 2, 3, 4. Okay. I knew it looked a little different. I was wondering why. Okay. Ugly, ugly triangle now. Alright. So I guess I could use the same, huh? Alright, so if you use the same, put now your pencil on the origin, which is the dot right there, 0, 0. And it doesn't matter which way you go. You can go left or right, counterclockwise, clockwise, it doesn't matter. We're going to do 1 turn, and then we're going to do 2 turns. So it should be like somewhere right about there, right? Does everyone look like that? You guys see it? Okay, so we're going to try to write down these points, and I have x prime is -3, +1. I can fit it here. And then y prime is -5, +4. And then z prime is -1, +5. So what happened to these points, you guys? Did you notice? What happened to all 3 of our points? How did they change? Look at the original numbers. We went from 3, -1 to -3, +1. What's going on here? They all changed signs, didn't they? Does that make sense that they would change signs? Because we went from quadrant 4 to quadrant 2. And now I can graph this. I can do -3, +1. That's x prime. -5, +4. Y prime. And -1, +5, z prime. You don't have to use the paper, but don't you think it makes it easier? Yeah, if you're really good at just figuring out symmetry, then you probably don't need it, but I'm not very good, especially on the 270s and 90s. I could do 180 probably. So the paper is something you want to hang on to, like especially for tonight when you're doing your homework. Okay, so don't lose it. You'll get another paper on Friday, but this is all I'm giving you right now.